Conditional probability part 2. Assume that 2 cards are drawn from a standard 52 card deck. Find the following probabilities. Assume the cards are drawn without replacement. That means that you're going to draw 1 card out, and then still holding that one, you're going to draw a second card, but there's only going to be 51 cards to choose from the second time. So find the probability of drawing a face card followed by a non-face card. Okay, so the probability of drawing a face card. Your face cards are the Jack, the Queen, and the King. There's 1 in each of the 4 suits. So 3 cards out of each of the 4 suits is 12 face cards. So since we're only talking about face cards and non-face cards, we've got 12 face cards. That leaves 52 minus 12 is 40 non-face cards. The probability of drawing a face card when there are 52 cards, the whole deck, and 12 face cards would be 12 out of 52, which would reduce to, let's see, 3 out of 13. The probability of drawing a face card and then a non-face card. So this is where the first is a face card. The second is going to be a non-face card. There are still 40 non-face cards left, but there's only 51 cards now. This fraction's not going to reduce. 40 divides by 2 and 5, neither of which will go into 51. So we've got 3 out of 13 for our first probability, 40 out of 51 for our second probability. Because we have to do both of these things, we have to do the first one and the second one, which makes it much more difficult. We will multiply these. Let's see if it's going to reduce any. 3 goes into 51 17 times. Not going to get any more reducing out of here. So this is going to be 40 on the top. On the bottom, we got 13 times 17, 221. Let's put this in. Fantastic. Now, on the second one. The second time around, we're looking for drawing a face card followed by a non-face card. So the same, but this time is with replacement. So the probability of drawing a face card on our first card is still going to be 12 out of 52, which is going to be 3 out of 13. Hasn't changed. The only thing that's changed is that the second time, we're going to put this card back. And the only effect that's going to have is that out of the 40 non-face cards, we're still going to have 52 cards to pick from. So the first draw is supposed to be a face card. Probability is 3 out of 13. When we draw the second card as a non-face card, there are 40 non-face cards, but there's still going to be 52 cards this time. Could have put it over on the other side, couldn't I? So let's see, 4, that's going to be 10 out of 13. So to do both of these things, we've got a probability of 3 out of every 13 cards is a face card. That makes sense because there's 13 in a suit. 3 of them are face cards. The probability the second time of a non-face card is 10 out of 13. Again, there are 10 non-face cards out of every suit of 13 cards. Nothing's going to reduce, so the probability is going to be 30 over 169. If we go ahead and put this in, lo and behold. So the only difference now was that the second time we put the first card back, and instead of reducing it to 51 cards, there were still 52. Well, let's take a look at this. The container contains 45 green tokens, 5 blue tokens, and 4 red tokens. 2 tokens are randomly selected without replacement. Compute the probability of F given E. So we want to know the probability that the second token is blue, that's F, given that the first token is blue. Now, they are not asking what the probability of selecting 2 blue tokens is. We don't have to figure out the probability of the first one and then multiply by the probability of the second one. They only want to know the probability that the second token will be blue if the first token was blue. So the probability of F given E, I'm just going to abbreviate it down to that, the probability that the second token is blue, if we have already removed a blue token. Well, let's see, what did we start with? We got 45 and 5 is 50 and 4 is 54. So originally there are 54 tokens, of which 5 are blue. Now, E, the first event, is that we select a blue token. We only are interested in the probability of the second event, which is the second one being blue. So first of all, we have to figure out what we've got when we get ready to pull the second one out. If the first token was blue, and this is without replacement, that means we are now down to 4 blue, and we only have now 53 tokens. So the probability of getting a blue token the second time, given that we've already removed 1 token and it was blue, is now going to be 4 left out of 53 tokens. Let's put that in, make sure they like that answer. Good job. Okay, we're going to draw 3 cards without replacement from a 52 card deck. That means the first time there's 52. Without replacement means the second time there's only going to be 51 cards. And on the third draw, there's only going to be 50 cards. Now, we're looking at drawing exactly 2 cards from the set of cards that are 2s, 3s, 4s, and 5s. There is a 2, a 3, a 4, and a 5 in each of the 4 suits. So 4 cards each from 4 suits is 16 cards. So this set we're looking at contains 16 cards. So the set of 2s, 3s, and 4s, and 5s times 4 suits is 16 cards. The set of the others, well, let's see. 52 minus 16 leaves us 36. So there's 16 in this set and 36 in the other set. So the set of the others. Now, the other thing is that it says exactly 2 cards from this set, but that's out of 3 draws. So if we call this A and we call this B, then we could draw an A and an A and then a B and have, out of 3 draws, 2 of these cards. Or we could draw from this set first, from the others second, and then get one from the first set again on our 3rd draw. Or we could even draw, say, an 8 the first time, and then a 2, 3, 4, 5 the second time, and a 2, 3, 4, or 5 the 3rd time. So there are 3 ways to accomplish this. Now, if we get an A and then an A and a B, in other words, one from here, and then one from here. So there's 16 to draw from the first shot, 15 for the second card. This is without replacement. We've taken one of these out. And then the 3rd card would be from the set of 36. So the probability here, let's see what this will reduce to. Let's do it this way. This is 4 out of 13. There's 5 out of 17. 18 out of 25. How else can we reduce this? Well, let's see. 5 goes into 25 5 times. We're looking at 4 times 18 over 1105. Now, this is the probability of getting a card from the set A, another card from set A, and then a card from set B. 72 out of 100 out of 1105. Now, the neat thing is that the probability for this set and the probability for this set and the probability for this set are all going to turn out to be exactly the same. Because if we look at the ABA, we're still going 52, 51, and 50 on the bottom. An ABA would be 16 possibilities the first time. A B is going to be 36 cards to choose from. And then a second A, because we're not putting them back, drops down to a 15. So the numerator is still going to be 15, 36, and 16, same as before. So this is also 72 out of 1105. And the BAA well, again, we got 52, 51, and 50. We know the bottom's going to be the same. The B first is going to be 1 out of 36 cards, the others. And then an A, well, we haven't drawn one yet, so there's still 16 of the 2, 3, 4s, and 5s. And then for the second A, there's only going to be 15. So again, we've got 36, 15, and 16. So we've got 72 out of 1105 is the probability of getting this. And then we've got 72 out of 1105 is the probability of the second one. 72 out of 1105 is the probability of the third one. Now, this is not that we have to do this and this and this. We can do either this or this or this. When it's an and, for instance, to get an A and an A and a B, the ands, for the ands, we always multiply. For an or, we could either do this one or this one or this one. This gives us 3 possible chances. So no matter what we get the first one, and actually no matter what we get the second one, unless it's another B, we still got a chance. So for these, because it gives us a better chance, we add these. That makes it bigger. When you multiply fractions between 0 and 1, it gets smaller. When you add fractions between 0 and 1, the answer gets bigger. So we're saying this, plus this, which would be the same thing as 3 times 72 out of 1105. So we've got 216 out of 1105. Let's try that answer and see how it works. And somewhere down in here, we can see that we did a good job. So in this problem, the situation was that there were 3 different ways to accomplish what we needed to do. So we had to get the odds for each of those 3. And then because that gave us 3 opportunities, 3 chances, we add each of those. Let's look at one more. Here, we're going to roll a pair of dice 2 times. So we're going to roll both dice twice, find the probability that a total of 3 is rolled each time. We got to roll a 3 2 times in a row. So this is going to be multiplied. This is not an extra chance. This is not roll a 3 one of the times, or at least one of the times, or at least 1 3. No, this is a 3 twice. This is harder. So what is the probability of rolling a 3? Well, the only way to get a 3 out of the 36 possibilities, there's 1 2 3 4 5 6. Okay, this is really sloppy, but it's kind of there. So we got a 1 2 3 4 5 that we could roll on the first one. A 1 2 3 4 5 we could roll on the second one. How many ways can you roll exactly a 3? It actually has to either be a 1 and a 2 or a 2 and a 1. 2 of these 36 would give us a 3. So the probability of rolling a 3 is 2 out of 36 or 1 out of 18. Again, the probability of rolling the second 3, because we don't have to worry about replacing the 3 on the dice, right? So the probability is the same for both times. So again, the probability of another 3 is, of course, still 1 out of 18. So the probability of a 3 and a second 3 is going to be 1 out of 18 times 1 out of 18, and 18 times 18 is 324. Type an integer or a fraction. So it's 1 out of 324. Let's see how that goes over. Well done. This is only a conditional probability given that the first time we had to roll a 3. And then if you didn't roll a 3 the first time, there's 0 probability of following through. So it really doesn't matter. The probability on the second one of rolling a 3, given that the first one was a 3, is still just the probability of rolling a 3. Because the first roll had no effect on the probability for the second roll. These take some practice. You got to learn how to interpret these. You've got to learn how to analyze them. But you can do this. You've gotten this far. You can definitely get this done. So we'll see you later. There should be part 3 coming, and I'll talk to you then.